Welcome to the Data Science Festival. Thank you all for coming and helping us create such a thriving community. We ask that you switch your phones to silent. The Data Science Festival is a celebration of all things data. We aim to connect the tech community and foster the sharing of knowledge, inspiration, and ideas. This event is free to attend and built by the community. Without the help of our sponsors, we couldn't make this event the success it's been. And so, thank you to Attest, Barclays, Bumble, CFC, Data Idols, Databricks, Deliveroo, Digitas, DirectLine, Danambi, H2O.ai, King, Mark & Spencer's, OpenCredo, and finally, CodeNote, who have also provided us with such a great venue. This year, we're not handing around the microphone for the Q&A, so please try and speak loudly, and I'll try to repeat your questions if not. And our first speaker here today is Enrique Muñez de Cote, and his talk is about building the AI city. Enrique's passion is to build tech companies that help solve some of the world's most pressing problems. He is the tech co-founder of Dark Matter Ventures, a catalyster of blockchain technologies, and Gekomatics, a computer vision AI intelligence for public spaces. An associate professor at INAOE and a member of the board of directors of the Associates of Trading Agent Research at TAR. Enrique, everyone.
Hi, guys. Thanks for the intro. Sorry for the delay. All right. So, yeah, I work at People AI. So these three things. Past, I was a director of machine learning at SecondMind, a company based in Cambridge doing machine learning for automotive nowadays. People AI, it's a accelerator for AI ventures, and Gekomatics, which is probably going to be spending some time there because it's a computer vision application for smart cities, exactly. So the agenda is to show you a little bit about what smart cities are nowadays, the current challenges, go specifically through these geodata example of smart cities. Obviously, not everything is about geodata, but a lot of it is. And specifically through the lens of computer vision. Spend some time thinking about the future of smart cities and the challenges to build such cities, and some of the stuff that we're currently building around that. So just to get started, a bit of motivation about this. So smart cities is really a bunch of interconnected services and components, technology, and but mostly kind of like functionalities. So we can think about smart government and everything that is kind of smart about the city, at least in theory, not yet in practice. And one of the interesting questions about that is well, how all this data comes together and the current challenges that because it all seems quite straightforward. Let's just put everything and take it from there. But so this talk is not about regulation or protocols or security, which are very interesting things to understand about the data part when building smart cities. Instead, it's going to be more about the current state of the art and specifically a use case on computer vision, a little bit about touching about the governance of smart cities, everything around data, and think about how we can design the next iteration of AI cities through the lens of complex systems. So I think smart cities is really complex problem needs for these kind of technologies. So very just high level, just to motivate the current what's going on with data. We can see something like that, unstructured data on tabular form. It has probably some tags and probably some addresses, and this list continues probably pretty big. And we can include time as well, meaning that there's probably these tags are more like events or assets. It could be really anything. It could come in many different ways, as a JSON format, as a tabular form, and we can start to see, well, the complexity of managing such type of data, especially the unstructured bit of this type of data. But really, when we're thinking about designing smart cities, some of the challenges is specifically about security, definitely. One of the major things. And these are the kind of components that we need to start thinking about when, before we start designing the cities. Okay, cool. But from a people perspective, it's more about, the current challenges are more about like adoption, really. Like, this is going to be new technology. How is people going to react to this technology? Is there going to be enough adoption about that? So cultural challenges, that's a very interesting one. We want to have technologies that actually are inclusive, like everybody's included in those. And that's also touches on this disability component. We need these technologies not to be a barrier for everybody to use them effectively. And then probably when we're deploying such technology, not thinking about before, but actually when we're actually using it, the challenges are more related to, like, how is this future-proof? Is this technology going to be useful in the future as well? Kind of like the theoretical challenges there. The infrastructure, is it going to be able to connect with all the different components? And so on. The list continues. So these are some of the interesting examples around that. And going a little bit deeper about the mapping data of public spaces, that's the stuff that we're doing at Gecko-Matics. And going back to this type of problem, this is the type of data that we're going to be seeing. But really, this is a lot better way of representing the same data. And because what you probably want to do with this type of data is to make decisions on top of it. Maybe if we have, like, for example, road damages, if we locate it geographically on a map, it's a lot easier to think about that problem and how to solve it in this type of format rather than this. Like here, probably the way that we would start tackling this is go one by one, first in, first out, try to go through that list and get rid of those problems. But when we see it like this, it's a lot better for algorithms to start planning about how to tackle such challenges. So maybe we can start creating squads that probably can tackle a specific area in time and in space. So a lot better, really, for managing this type of information. However, how do we actually do that? So we have Street View. We've all seen this type of footage. Very cool. So how can we? So computer vision, it's really to try to get inputs like this and get out objects, like what's happening in those scenes. But what's very, very challenging about these, specifically about using this use case or this type of data, is that probably it's very outdated. So if you're really thinking about capturing stuff online, as in what's happening right now, this is going to be like totally outdated. Even for passive, right? Like when we want to probably have a catalog of all the different assets that a public space has, such as street lights and road signs and everything that is contained that is not moving too fast. Well, having a picture of 2017, probably things have changed quite a bit. So also there's this problem about restricted license, dependability of a third party. That it's probably not the best way to do that. If they decide to just get rid of a license, then we're going to be out of business. So and also tackling large scale on this type of solution is pretty hard. So what we actually do is go and collect data ourselves. So we have a bunch of sensors. we go and just like a Google car, we go and collect all the data. We put it into this big thing, AI cloud, which is basically doing clustering and classification on top of a bunch of computer vision classic things like identify features and so on, to spit out something like this. So some layers of information that can be digested for different applications. So talking about some of the challenges on how to do this, I'm going to just touch on these 3 points. There's a lot more to it, obviously, but I thought that for the time limitations, probably these 3 are easy enough to just get our idea of the type of challenges that this type of application might have. And specifically on GDPR, so try to get anonymity on these. We're going to touch on these license plates and face recognition. But just to get started, probably it's important to just define what GDPR means. And what we really want to not do is have information stored that can identify one's identity. So these are possible examples of type of data that could identify somebody. And the specific 2 pieces of information that are encoded into an image could be like a face and license plate. Those 2 things can recognize you pretty fast. So how can we be GDPR compliant in this space? So this is the kind of the pipeline that we would go through. Start with detecting faces and license plates. Run that image through an anonymization process. Maybe apply some algorithms like Gaussian blur or some irreversible color overlay, and then destroy the original image and play with only the image that has been already anonymized. So more specifically, there are some. This is just a possible example of open source technology that could be used for a problem like this. Starting with a data set. Coco is a classic data set of images of all different instances. With this type of data set, we can train algorithms to start classifying different objects on a scene. And then with that classification algorithm, we can start identifying, is this a car, is this a person? And then run that through another algorithm, also open source, that will be able to identify the different type of objects. So one pretty much segments and thinks about the possibility of being a car or not, and the other one actually does the classification. So more specifically, it looks something like that. Starts with an image. This is probably a 360-degree image that needs to be encoded in a different way so that it's compatible with Coco type of images that are like on 2D, such like this. Identify the possible object, and then do the recognition and apply an algorithm to do the anonymization bit. And do that with everything that could be license plates, for example, or faces. Same process applies for faces, the exact same thing. And what we would have when we step a little bit farther out, when we zoom out, is we have video feeds, go through anonymization, identify the object, and then we end up with stuff like this. Perfect. OK. A very interesting example, obviously, is false positives and negatives. We probably have all heard about these things, especially in classification algorithms and machine learning. These are just, we want to get rid, so these are machines trying to make decisions. Just as humans, we're going to be making some mistakes. What is, especially if things are like out of focus or very far away, we start making more mistakes about what, is this a car or not, or is this a person or not. But even more challenging, so those are the classic classification problems, the false positives and false negatives. But for this specific scenario, it's even more interesting to start identifying stuff like this, and these could be also false positives, a little bit on a more complex type. So rubbish versus a rubbish bag, 2 different concepts, very related. It's almost semantically a semantic problem. Is this a single large object or a multiple small ones? Which are the types that we're interested in identifying? But there's also kind of legal or legislation type of things, which is, do we want to classify stuff like this, cop or on the street? Is that legal or not? Do we actually, are we interested in capturing such things? All right, and another type of object is sensors. Sensors have bring a lot of error with them, and we need to have ways of dealing with those problems. So a simple, it's called an SFM pipeline. SFM it stands for structure for motion, and that is the process that an image goes until we get something like this, which is a 3D representation. It's called a point cloud. So basically, it starts with video feeds. Video is nothing but a bunch of images interconnected in a way. From those images, we start extracting some features to try to understand which images are actually a match. Basically, it's the same object repeated in the same image, which is a very hard problem to solve, actually, especially when we think about stuff that might be repeated, that algorithm can make easy mistakes. A traffic sign, for example, there's probably more than one traffic sign that look exactly the same, and an algorithm will have a hard time identifying is this the same object or not. Hope that's clear enough. So basically, we have video, a set of images in time, and what we want to do is make sure that two sequential images and ask the question, is this the same object in those images, or are those different objects? And when we start understanding that it is actually the same image, the same object, we can start producing these things. So the way to produce these 3D representations from 2D inputs is by having a bunch of images, and do the same trick that we do as humans with our eyes, stereo vision. Basically, that means that once we have the images, we need to understand the origin where that images was taken from. And when we take sequential images, then what we're going to have is something like this, where we have an origin, a shoot of the image, and then another image, a shoot about that image. This is the same object captured from two different positions, and through an algorithm which is uses nonlinear optimization, it kind of puts everything together and represents what it was previously a pixel into a 3D representation, which is now a voxel. If you want to know more about that process, that's a link to that. Pretty cool stuff. Nothing particularly innovating about this, except for the fact that actually when you try to do this in real life, this actually doesn't work out of the box. But good for starting some experimentation, definitely. And this is what we're going to end up after taking some, like a lot of video feeds. This is the 3D representation of a point cloud, a sparse point cloud, as in if you zoom enough in, you're not going to have enough data points. But then you need to fill in the blanks, and then you can start doing pretty cool stuff. But talking about the specific error about this, it's actually a GPS error. And this is how it looks like. So this is the same. This is the object that we're trying to recognize, shot taken from two different positions. And this is the error made. So this is the actual position, and this is the position that the GPS brings. And here the problem is that when we compare these two things, the error actually is pretty different here. And so what we really want to do, this is a lot better. This is the same error displacement between the green and the red dots. But the result, it's a lot different. Like in this, when we try to shoot things from when the two images are pretty close together, we're going to be having a lot bigger error. So this is how it looks in reality. So basically, through a lot of experimentation, we find the kind of correct angles, which is enough apart shots to be considered to do this. What we really want to do is understand how far away an object is, right? voxel of that object. So this is something that we might be interested in, capturing how like the angle between our front view and the object. If it is if the angle is less than that, then we're not going to be considering. So in shot from up, it would look something like that. So that's something that this view we might consider to use and inject into an algorithm. This one we might discard it because it doesn't have the correct angle. All right. So with those kind of tricks, we can get rid of with a bunch of inherently problems that we're not going to be able to just get rid of by correcting it, by just looking at the data and correcting the data, rather than just understand that the nature of the problem is actually flawed from the get-go and try to start from there. So the kind of view of how, or the promise about how smart cities really look like, something like this, which we have smart governments and all the different components of a smart cities and what the kind of components that they bring. And this specific application that we just saw kind of touches a little bit on all these different things: smart living and government, especially government because the government is interested in digesting this type of data, but also definitely mobility, and especially companies that are doing kind of autonomous driving and things like that. They want to digest this type of data. And a smart environment, this also, we didn't see this coming, but it's a pretty interesting application that smart governments, they're trying to consume this data to try to understand green spaces, how green a city is basically. And if we have capabilities, because we can represent this in 3D, we can measure volume of green space, put everything together and try to understand stuff like CO2 consumption and things like that, which is very, very interesting for future applications. However, the technology that right now we're building is around this area, and this is what I'm going to be talking about a little bit more, which is more about the future. It's probably smart cities are not there to tackle these problems, but we have the right kind of technologies to think about those. And some challenges on those two specific things are not exhaustive list, but probably some of the most interesting challenges happening around that area are these 5 points. We're going to touch a little bit on this specific one, on governance. I don't have time to talk about simulations, but that's something else that we're also doing a lot. So it all started really, and this is just motivation. This is a pamphlet, 1833, if I'm correct, that William Lloyd started discussing about different phenomena that was happening when you have this called the tragedy of the commons, and the real thing was, think about it like this. This is overgrazing of cattle actually, and the questioning starts like, if you have a common piece of land where anybody can use and exploit, and let's say that you have cattle, 4 players sharing this common space, each of them owning some animals. The question that each player might be asking themselves is, should I add an extra animal there? And if it makes economic sense to add an extra animal, they will do so, most probably. And that's a problem, because if everybody does that, then they're going to exhaust the resource. However, William Lloyd actually discovered that, in comparison, that those commons compared to privately owned grazing land, the privately owned didn't have this exploitation element. And the real answer to that is that when you have these commons, you're acting on your short-term self-interest. And here, when you're owning that piece of land, instead you're looking at the long-term economic consequence of that. So interestingly, how can we solve things like that with the current technology, and especially through data? And it seems that we're actually getting into very interesting. So obviously there's Nobel Prizes and everything that has been to try to understand that problem and bring some cool solutions. But there was this technology level that was missing, and I think we're there now to try to start solving some of these problems. And that's exactly what we're doing here at Dark Matter. It's deep technology company accelerating ventures for these specific type of problems. But more specifically, what we're really doing is trying to empower system designers, such smart city like municipalities. They're trying to design systems. These systems these guys are the system designers. We're building tools for those people to design better systems. All right, so this all starts by understanding really that cities, for example, are decentralized by nature. Meaning there's going to be IoT systems from competing companies. There's going to be humans in the loop. All of these things are totally decentralized. And really, when we usually think about these systems, we think them as a global authority trying to impose some kind of rules into the system. And we're trying to flip that around and think from the get-go that this actually is a decentralized system. And we need to have solutions that think about it that way. But really, reality is actually decentralized, right? When we see really ecological systems, they're definitely decentralized. They're not like connected through one single hotspot or something that they're kind of coordinating through that. They all have their own code, and they're acting on based on that code. But they are also interacting with each other, so they're actually creating a community around that. So that kind of view of nature-inspired design, that's what gets us very exciting, and we can solve problems like this, like how to use commons and how to empower employees within our organization with the same kind of technology to do this. So specifically for using the commons, for example, if we have the right kind of programs in place, we could surpass these type of things. What does a program actually mean here? So just to try to take the view back on kind of a coordination of different players, which is what really happens on these type of problems, we might want to think about centralization versus decentralization. And centralization looks something like that, where there's one big decision maker kind of coordinating what happens in kind of a tiering system. And in a decentralized way, there's no like this tiering system. Instead, there's just like local coordination happening. And kind of the very interesting thing is, what previously was this type of design, can we achieve the same kind of results or even better through this type of thinking? Obviously, there's not like a silver bullet thing. There's going to be some overhead to pay for doing those changes, especially about the amount of data being communicated, for example. Here we probably need to send 5 messages. Here there's going to be a lot more messages happening to achieve coordinated decentralized coordination. But what is very interesting now is that we can add this layer of programs and think about that like these are like the interaction rules that could happen and would allow these peers to interact and coordinate better. And well, blockchain is a possible technology that we could use. We're not definitely tied to the term blockchain. It could be many other things, but we believe that blockchain is probably a good technology to think about these things. However, it does have this kind of trilemma. We cannot achieve scalability, security, and decentralization at the same time, so we need to pick 2 of the 3. So we might want to be on this line where we achieve scalability, meaning that this actually solves a problem on big scale, and also make sure that it's a secure system, but we're at the risk that probably we're going to not be completely fully decentralized. All right, well, that's mostly it. We have probably some minutes for...
Yeah, we do. Thank you, Enrique. If anybody has any questions, just raise your hand and we'll come over to you.
Hello. Hey, not really a technical question, more of like a practical one, I guess. So in one of the slides, you showed a picture where we're trying to detect like cardboard on the road, right? Which obviously, I guess, is like a negative thing for the local community. But I guess one kind of obvious problem of kind of having, I guess, automated systems to detect these kind of things is like the privacy element, right? So it's like, is the value exchange strong enough for the citizen where you have like a live feed of the camera monitoring cardboard in exchange for them, like having like a better service of cardboard removal? So I guess, yeah, I was just curious about what your thoughts are on like how we can, I guess, how you can tackle that kind of, I don't know, like cultural perception barrier, I guess, because obviously we think that it's like for the greater good, right? But how do you work with that?
I guess you mean like this, the idea that we're being watched. Yeah, I think anonymity probably can go a long way. As in, we're not watching individuals; we're watching what's happening on public spaces, and public spaces needs to be kept, and it's not something that is going to come for free. So there's obviously some management to be done to achieve what's better for everyone. And yeah, I think anonymization can really go a long way. Maybe that's really my answer. Like it's not about detecting people. That starts to go into a gray area when you're thinking about detecting people and what they're doing, how they're fighting, which is probably a good application as well, right? But that just starts to go a lot more into that area. Here it's just detecting like public spaces and what's better for society, not to have rubbish on the streets or not to just observe anything.
I don't need a mic, I'm very loud. You had 6 areas there of smart cities that you wanted to focus on, and you said that economy and people were what you were focusing on for the near term. Are you able to give some practical examples of issues that you solved in those areas? Without telling us the client, of course.
Yeah, absolutely. Smart economy. So there's definitely I think the most interesting one would probably be the one about organizations. So organizations, we know there's a gap in different generations that on the type of work. For example, work environment. Do we work remotely? Do we work in person, like physically, or do we work part-time? And all that flexibility, I think that's one very interesting problem where organizations, new type of organizations, using this type of technology can enable all these different type of collaboration. So if somebody has willing to contribute probably like a couple of hours a week, that's still useful enough, and probably we have the resources and the tools to make that happen. Whereas probably in classic organizations, that would be a lot harder to achieve. So that's probably a very good example on the type of organizational level programming an organization in a way that all kind of contributions are welcome and useful, and that's probably a very good thing for the future.
All right, thank you guys. If you have any more questions. All right, we'll now take a short coffee break and reconvene in this room at 11 a.m. Thank you.